In this video, what we're going to do is talk about the scientific method. Now, I know you've heard about the scientific method since you were in grade school. Scientific method. But we want to talk about it in terms of the actual process and review some of the things that you've talked about, and perhaps think about the scientific method in a few ways that you have not thought about it previously. The way our brain works is we have two sort of different types of thinking or reasoning. There's what's called inductive reasoning and deductive reasoning. Inductive reasoning is where we sort of discover something about the world around us. And then we can apply that to the greater world. Deductive reasoning works in the opposite direction. So it's taking sort of what we know about the world and applying it to a specific situation or a specific problem. So this is, the inductive is sort of discovering some small change and applying it to the broad world around us. Deductive reasoning works the opposite way. We take our understanding of the world around us and apply it to a specific problem. Our brain does both of these things all the time, but in the scientific method, we tend to use one more than the other. We tend to use deductive reasoning more than we do inductive reasoning. And so if we think about what is the first step of the scientific method, we have to make some observation. We have to see something. And then we say, oh, that's kind of weird. What is going on there? So we'll ask a question about that particular observation or phenomenon. We want to understand what that is. So we would take our understanding of the world around us and try to make sense of what it is that we're seeing by asking the appropriate questions. And when we do that, we formulate a hypothesis. All right, so I'm going to ask you, what is a hypothesis? And I'm betting I can guess. I have a hypothesis about what you're going to say. I think you're going to say it's an educated guess, because that's what you've learned way back in grade school and has been pounded into your head forever and ever and ever, which is fine. It's not wrong, but at a college level, we want to think about something a little more specific than an educated guess. We want to use this reasoning, deductive reasoning, and so we do something called hypothetical deductive reasoning. Sounds fancy. Really, we're just taking a hypothesis and thinking about it by taking our worldview and applying it to that specific problem. So perhaps a more specific definition for a hypothesis than an educated guess is a tentative explanation for our observed phenomena, whatever it is that we have seen. So this is, given the evidence we have, our understanding of the world, we think that's what's going on here. And then what do you do from a hypothesis? You make a prediction. Oftentimes, predictions come in an if-then or if-then kind of statement. If my understanding of this is correct, my hypothesis, then this is what I think is going to happen. So a prediction often follows from the hypothesis. If my tentative explanation is correct, I expect this to happen in the future. So if every swan I've ever seen has been white, then I expect the next swan that I see will be white also. If every swan that I've ever seen has been black, then I expect the next swan that I see is going to be black. So from the predictions, then what we have to go and do is do some sort of experiment. So this is where this hypothetical deductive reasoning is coming in. We are trying to come up with, from our predictions, ways to test that. Are we actually correct in our hypothesis or not? And we have to be careful. We can't prove that we are correct. We can just gather evidence for something. So we test our predictions using experiments, and we end up with our results. And the results are either going to match our prediction or they're not. If we've done everything correctly when we've set up our experiment, we're going to have some understanding of whether we have support for our hypothesis or not. So if our results support our hypothesis, then we move on and we think we understand that. If the results do not support the hypothesis, we have to sort of rethink this. So we come up with new hypotheses, make new predictions, and go back and test those experiments again to try and refine and get a better understanding of our hypothesis. All right, so this is one way of thinking about the world, and in order for this to work, science is going to have to use facts and be repeatable. We can't just see something and never be able to see that again and have that be science. So that's not, it's a way of thinking about the world, but it's not a scientific way of thinking about the world. So we have to, what do we mean by facts? We can have measurements and observations that other individuals can do and will come up with the same sorts of results that we do. So let me give you a little example here. My bicycle is bigger than yours. Okay, so that's a statement versus my bicycle is more interesting than yours. So one of these things we should be able to test or approach scientifically using these steps. The other we cannot. So which one would be scientific and which one would not be scientific? I'll let you think about that. Basically, the problem here is these two sets of words. If I go and measure a bicycle in whatever way that means, how tall it is, how much it weighs, how big are the tires, how long is it, all of those different things, those are things that we can take measurements on. We can take out a ruler or a scale or whatever it is that we're using and come up with numbers and observations for those. And that can be repeatable by other individuals. I can do it more than once and come up with the same numbers. I can measure it and then you can measure it and we come up with the same numbers. We can address these things scientifically. My bicycle is more interesting than your bicycle is not something that we can take out a ruler and come up with a number for. This is more of an opinion, and people's opinions differ, and people's opinions change over time. So this is not a statement that we could address scientifically. So all of this is going through the scientific method. Once you've addressed some sort of big kind of problem or big set of observations, then what we can do is say we approach it using a variety of different observations and ask lots of different questions. You can come up with, I'm just going to write right in front of me, a scientific theory. So a scientific theory this is one of those words that's problematic in science because, or in everyday language, because people use it in everyday language in a way that's different than we use it in science. In science, a theory is something that is very well demonstrated, very strong, has lots of different lines of evidence supporting it. Versus in everyday language, we say, oh, I have a theory about that. That's not technically correct. You don't have a theory about that. You may have an observation or you may have a hypothesis about that, but in a scientific sense, theory means lots and lots of different explanations. So for example, plate tectonics is a theory. So the plates of the Earth move around and bump into each other, and it's supported by lots of different lines of evidence like earthquakes and volcanoes and mountain ranges and deep ocean trenches. All of those are different lines of evidence supporting plate tectonics. So all of this, we've got sort of three things we're interested in here. We have the scientific method, we have hypotheses, and we have scientific theory. And we'll use all of those in the process of science to go out and address questions that we're interested in. So hopefully this makes sense, and hopefully you enjoy it. Thanks.